This is section 911A. We're going to introduce identities. So we're going to use identities to manipulate an expression or equation. Now, these are the identities that we know so far and that we're going to need to know and memorize. We know our reciprocal identities. Sine of an angle, so in this case sine of u, equals 1 over cosecant u. That just means the reciprocals of each other. Tangent is sine over cosine. Cotangent is cosine over sine, because tangent and cotangent reciprocals of each other, so that's why they're flipped. But now we're going to introduce new identities called Pythagorean identities. Now, we only need to know or memorize these three here, but just know that you can manipulate them by getting whatever term you want by itself. So here's the three identities. We call these Pythagorean identities because you can derive these identities from the Pythagorean theorem. So the first one is sine squared of u plus cosine squared of u equals 1. It'll always be true. The next one is 1 plus tangent squared u equals secant squared u. And then we have 1 plus cotangent squared u equals cosecant squared u. Now, technically, this is the only one you need to memorize because you could derive the other two from it. So, for example, if I divide both sides by sine squared u, now if I did that, sine squared divided by sine squared equals 1. Cosine squared over sine squared is cotangent. 1 over sine squared is cosecant, because 1 over sine is cosecant. Cosine over sine is cotangent, right? So you can derive the other two by either dividing by sine squared or dividing by cosine squared. So just in case you forget. Now the alternate forms are just getting each term by itself. So if you notice on this first one, 1 is by itself. Well, if I were to, subtract cosine squared and bring it to the other side, now sine squared is by itself. Or if I were to subtract sine and bring it to the other side, then cosine squared is by itself. So it's whatever you want to get by itself. That's basically the way to remember it. Now, you don't have to memorize these, but they're going to come back, and it's almost like one of those things where it's like it's hard to see, and it's like you should just try it, but they're just Pythagorean conjugates. So remember conjugates: a plus b, a minus b, a minus b, a plus b, right? A minus b, a plus b. So they're just conjugates of each other. But basically the idea is when you multiply the conjugates, it completely changes like what it is. So for example, if I multiply cosine conjugates, I end up with sine. If I multiply sine conjugates, I get cosine. If I multiply secant conjugates, I get tangent. If I multiply secant and tangent conjugates, I get 1. Right? It's like this weird thing where when you just multiply them, you get something different. And so if you are able to memorize them, it's just helpful. But it's going to be one of those things where, like I said, you're going to see it in the future. You're going to be like, I don't really know what to do. It's probably a conjugate. Now, when we go through this, because basically we're doing proofs. Okay, so we're proving one side looks like the other. Now, when we're doing this, if you kind of follow these three things, it kind of helps the thought process. So the first, we want to use our larger identities. Pythagorean, double angle, sum and difference, half angle, power reduction. Some of those identities we haven't gone over yet, but they're going to be these bigger identities that we're going to want to use. If you see them, probably means you're going to use them. Second, algebra. If you see something you can add it. If you see something you can subtract it. If you see something to distribute, maybe you should distribute it. If you see a conjugate, use a conjugate. If you can factor, maybe you should factor. Basically, it just means there's some algebra technique that you can perform. You should perform it. and then see what happens. And the last is sometimes you're just going to meet a dead end. There's nowhere to go. Change everything to sines and cosines, and then repeat back from the top and try again. So let's work through this. Let's use this logic to help us. All right, so first example. Now the first thing we want to pay attention to is how to set it up. You can only manipulate one side, only the left side or the right side. Now, usually the side you choose is the quote-unquote more complicated one, the one that gives you more stuff to do. And this is what I mean. So if I want to manipulate this, let's look at the left side. Pythagorean identities. Do I see sine squared, cosine squared, tangent squared, anything Pythagorean? No. Okay, so next thing. Is there anything that I can add or subtract or distribute? No. So then change everything to sines and cosines and then repeat. Well, 1 over cosecant happens to be sine theta. Oh, look, they're now equal. And so therefore it's solved. Now, I could have done the right side and changed sine into 1 over cosecant, but it kind of is outside the mold that I'm trying to help your thinking. So just know that you want to only focus on one side. If you use this process, you'll generally get to the answer. Let's look at another one. So in this one, the right side looks a little bit more complicated, right? The left side is tangent, the right side, sine theta, secant theta. So let's manipulate the right side. So do I see any larger identities? Pythagorean, double angle? No, I don't see sine squared or cosine squared. So next, any algebra? Is there things to add? Is there things to subtract? Do I need to distribute, etc.? The answer is no. The last is, let's change everything to sines and cosines, and let's see what happens. Well, sine is still sine, and then secant is 1 over cosine. So now let's start all over. Pythagorean? No. But algebra, I can multiply this together. Oh, sine theta over cosine theta, that's tangent. Now they're the same. And that's my answer. Let's look at another one. Left side or right side? The left side definitely looks more complicated. So, do I see any? Let's start with number 1. Do I see any larger identities? Do I see any Pythagorean or anything like that? No. Step 2, anything to add or subtract or distribute? Well, I do see these being multiplied, so it's distributing. So secant times secant, the secant squared theta, secant times tangent is secant theta tangent theta. Multiply those two, minus secant theta tangent theta, and then the last minus tangent squared theta. Well, these cancel out, so I get secant squared theta minus tangent squared theta. So starting back from the top, Pythagorean, hey, I see some secant squareds and tangent squareds, etc. And so my Pythagorean identity, and I'm going to write it off to the side, is 1 plus tangent squared equals secant squared theta. Okay, well, if I know that secant squared theta is 1 plus tangent squared, I can substitute it in. So that secant squared becomes 1 plus tangent squared theta. I still have the minus tangent squared theta, because that just brings it down. Oh, algebra, now those cancel out, and I'm left with 1. And that's my answer. Let's look at this next one. Okay, left side or right side? It's kind of interesting what's going on here. If I do the left side, if I do the right side, Now, maybe it's one of those Pythagorean, right? Because there's not really much going on. I also see that the On the left side, I see secants and tangents, and my right side is already sines and cosines. And if you look at this third step, change the sines and cosines. So maybe I'm going to have something to do on my left side. So let's focus on that. So secant theta, I don't have any Pythagorean, there's no algebra, nothing to add or subtract, so I'm going to change everything into sines and cosines. So 1 over cosine theta, that's what secant theta is, and then over 1 minus, and then tangent is sine over cosine. So now I want to try and combine this together. So to do that, I need to find the common denominator. So this needs cosine over cosine. So then I'm going to get 1 over cosine theta over, and then I get cosine minus sine. So then cosine minus sine, because I can combine these together, over cosine theta. Oh, remember, if it skips, so you can just cancel that out. So I get 1 over cosine theta minus sine theta, and that's exactly what I wanted. So what did we learn today? We talked about and introduced identities. It's something a little different. We're going to be spending some time working on it. But the idea here is we are manipulating trigonometric expressions using identities. And what's going to help us do it is by memorizing it. This does conclude our lesson. If you have any other questions, please leave them in the comments.